I'm not sure I really need to present a blueprint. You know, we have the BioE3 policy, we have ANRF, we have so many programs that is, okay, thank you. Uh, so many blueprints, so to speak, that are already in place, but all the same, I just thought there could be some perspectives, particularly after listening to Sandeep's fireside chat yesterday. I think I prepared the slides with some of the comments he had made, and so this is sort of, in some sense, specially made for BFI, right? So the the themes that really describe how I'm thinking about breakthrough biotech is really we are at a stage where we can rewrite biology, and I will explain that. We can redefine health, and we can reimagine the planet. Now, the reason, I think I have to point it this way. Yeah, that works. So I think it's important to realize that we are facing probably the most dangerous moment in human history. The Anthropocene is a challenge, and for young people in the audience, I don't know if Amrita is here, but we need to apologize. We are leaving them a planet which is actually quite damaged. But the good news is that whether it's issues of climate change, environmental degradation, food security, or health security, breakthrough biotechnology actually has some answers. And I recall that in 2001, when we were setting up ABLE, Kiran, Varaprasad, Vilu, myself, we had all come to meet Prime Minister Vajpayee to describe to him what biotechnology was and why this was a sunrise sector for the biotech, for the industry. And he got it right away. He said, "Samajh gaya main. IT is India today, and BT is Bharat tomorrow," right? So that is really our both our challenge and opportunity, and this is where biotech breakthroughs can play a role. Right? Now, the remarkable aspect of the history of science has been, I was born in 1953. That was the year the double helical structure of DNA was worked out, right? It was also 1950 that Turing wrote his famous paper and published it in Mind, and the whole idea that computing and data science was going to actually accelerate. Right? And if we see these two areas of molecular biology and information technology have been accelerating, and if I have to say that my timing was lucky because I got to ride both these waves. Right? I was trained as an information technologist, but then also got to work with the overlaps with molecular biology. And actually, we are at a very interesting stage now where you might say that Moore's law meets Mendel's laws, right? And just about 3-4 years ago, I think we suddenly saw that the $100 whole genome is a reality. Right? Today, And very soon, I think in India, we will have the capability to sequence 1 gigabase of nucleic material for $1, right? And this is an extraordinary acceleration. In fact, at the square of Moore's law, ever since next generation sequencing became a reality, right? And you can see there's sort of an inflection point, and then it goes really fast. And I think these sequences are already in place now. And we should, if you really think about it, the whole Genome India project could have been done in a year, right? If it was actually, if you're using the power of all of this sequencing. The interesting transition that we're starting to see is from digital technologies to living machines. Right? And I think this is really breakthrough time, right? Because I think particularly if you see the inflection point with AlphaFold and the fact that all this digital technologies, information technology, AI, whatever you want to call it, has now started making the possibility of designer proteins and what we can actually conceive of, we can create. Right? That's why Jennifer Doudna named the book A Crack in Creation, right? With CRISPR. So the fact that synthetic biology is now going to be able to do all kinds of things for us, and these are kind of the breakthrough biotechnology areas where it would be extraordinary if BFI can actually play a role in taking forward. Right? But as you can see, I think if the promise of living machines actually plays out, Viksit Bharat just happens. I think we have to build the capacity to get all this going, and once we do that, I think reaching goals like Viksit Bharat really becomes a possibility. But the other thing to remember is that scientific breakthroughs are happening everywhere. Right? This doesn't have to be the bastion of the Golden Triangle of UK or Cambridge and the Bay Area. It can happen anywhere. I mean, look at DeepSeek. Chengdu, how's it pronounced? Shu Qi, right? So DeepSeek, I think we all have to learn Mandarin, the way things are progressing. But it's pretty amazing. And it's not just, financial computing, fintech kind of AI. Think about where the drug industry is today, right? And 31% of the approved molecules, INDs, last year were actually originating from China. Right? So whether you talk about pharmaceuticals or medtech or nano, quantum, everything is happening everywhere. There is really no reason to think only about the West. Right? It's time to reorient, so to speak. Right? So the other aspect to think about came out very clearly in Dr. Bhargava's talk, which is that, I think we have to really think about sovereign biotechnology. And we have to look at biosecurity the way we have thought about security in general. Right? It's, whether these are man-made pathogens or naturally occurring ones. I think these, whether we are talking about public health or biodefense, these are two sides of the same coin. In terms of our being prepared and being able to respond, these are both exactly the same. And the unfortunate thing is that it's only when you think of this as a biosecurity threat that you will actually get the support that this sector deserves. It is, for one reason or another, the world has been a military-industrial complex. Right? Ever since the days of Eisenhower, I think science and advancement in technology is driven by the military-industrial complex. So if we can actually connect biosecurity as a real sort of national security threat, then we will get the resources that are needed to really drive breakthrough biotechnology. And by the way, this variant analysis map of the SARS-CoV-2 variants that emerged was work that was funded by BFI, right? And so that was the map that was created as we saw the variants emerge, and we were sequencing at Strand, and these were we were sort of helping the city of Bangalore cope with this. I think Harsha is in the audience. She was the scientist who was running the labs. And Dr. Bhaskar Rajkumar is here from Art Park, and he was managing the COVID war room for the city of Bangalore. And these sorts of information was flowing to the city authorities to be able to respond. So I think, again, breakthrough biotech is very, very critical if we want to think of sovereign biotechnology. And we need that sovereignty today. As we know, the world is sort of, globalization is kind of coming under certain threats. And we really need to think about sovereign biotechnology as well. Another way to think about sovereign biotechnology is to think about how we might move towards what we call point-of-care testing is how people think about it. But I really want to think about it one step further and say point-of-need testing, right? And how do we actually move towards point-of-need testing? This is going to require microfluidics, all kinds of new chemistries, CRISPR, various technologies that come together, edge computing, digital, semiconductors, electrowetting, and being able to put all this together will actually give us a different level of biosecurity, right? And again, this is a thought to ask agencies like BFI to really think about how to push this type of agenda. Now, one thing that you see in being able to pull off something like this is you have to have convergence. You have to have convergence of engineering, convergence of chemistry, convergence of biological research, and there's a lot of AI involved. There's all kinds of technologies coming together. So this is a movement, right, that we have to essentially foster. And so along with a dear friend, Raj Malhotra, who's in the audience, we've been thinking through how to make this convergence a reality, and particularly where we have so many academic institutions creating all kinds of interesting IP, how do we actually build on this? And the interesting thing is that actually blockchain and tokenization has an integral role to play in actually bringing all this innovation together and recombining and creating new value. So not only can blockchain for impact actually help support the various initiatives that create these assets, but actually provide the tokenization infrastructure to actually bring this together and recombine to create new types of value. So if this is of interest, I think Raj is here in the audience, and it would be great to pick up this conversation. I, have been thinking about how one actually puts together a master plan. And at the core of this master plan is a microbial repository. And many people are thinking along these lines. And we have been talking about it. And this morning I was chatting with Premnath about the microbial repository for industrial applications that NCL has put together. I think, there are various ways in which we need to take this forward. And, and I think, I don't want to leave quantum out of the picture, because I think quantum is also happening. And, but really, I think if you want to understand what happens inside the molecule at, in the quantum chemistry aspects of molecular behavior, that's where we're going to actually need the power of quantum to come in, either through simulations or actual computing qubit machines. I think this is, again, a great time to revisit an old DARPA program. The old DARPA program was called BioSpice. How do you actually study at a cellular level molecular interactions? And I believe that quantum now provides us with that next level of thinking about, a virtual cell, so to speak. Right? And once you can understand and simulate a virtual cell, there are all kinds of things that you can develop. So BioSpice version 2.2, funded by BFI, sounds like a great program to take forward. I just want to end up by saying, first of all, I'm so touched by this gesture of BFI to give me a Lifetime Achievement Award. But these things it takes a village, right? I personally might have done a few things, but it's been a great collective effort. I think, as was mentioned in the citation, Mr. Ratan Tata sort of opened the door for us to think about, starting companies from the Indian Institute of Science, and for the first time in India, at least, I think sanctioned entrepreneurship by faculty was made possible because of Mr. Tata, who was the president of the court of the Indian Institute of Science at the time. And the four of us were able to come together to create both the Simputer and Strand. And I think, the journey of the Gang of Four has been extraordinary. We still get together all the time. There are various startup ideas, and Vinay is doing his next startup. And, we were there last weekend to see the prototypes. So there's a lot of energy that just comes from being a group that continues to interact and work together. There's a whole ecosystem, right, that has been my personal sort of deep tech ecosystem, and Bangalore actually provides an extraordinary opportunity to interact with so many different agencies. But I must acknowledge my alma mater, BITS, because I think Ram Gopal and Dr. Wali and others are in the audience, and I know there are several BITSian alumni here. So, BITS Pilani was an extraordinary experience, and so much so that a few of my contemporary alums and I got together and actually created a company called CRISPR Bits, and you can actually see, in the exhibition area, some of the work that CRISPR Bits has been doing. And I think just a whole bunch of companies and startups and nonprofits and so on that have all been inspirational and have been, in some sense, what keeps me going at the age of 72. I still feel there's work to do, so that's just an acknowledgement. Thank you so much.